All right, this is the review for 5.3 and 5.4. So 5.3 is graphing our radical functions or radical equations, and then 5.4 is solving equations with radicals. So the first thing we want to do in order to graph, is let's write our standard form here is going to be f of x equals a, and then square root of x minus h plus k. Okay, a is your vertical shift or your stretch, right? So if a is greater than 1 or less than -1, then it's a stretch. If a is between 1 and -1, it's going to be a shrink or a compression. If a is negative, we're going to flip it across the x-axis. We're going to reflect across the x-axis. And if a is positive, we're just going to keep it the same as the parent function. Okay, remember your parent function for square root starts at 0, 0, right? And then you have 1, 1, 4, 2, and then 8, 3. All right, and then h and k are your shifts. So h is your horizontal shift, k is your vertical shift. So for us, we're going to have a equals 3, right? Square root of x plus 1. Remember, that's the same as x minus -1. So h here is going to be -1. Okay, and then k is going to be -2. So what this tells me is I have a vertical stretch, a vert stretch by a factor of 3. It tells me I'm going to go left 1, right? It's going to be a horizontal shift left 1 and a vertical shift, meaning down 2. Okay, equals -2. So down 2. Okay, my h and k is also my endpoint. So your endpoint is also going to be hk. So I'm going to have -1, -2 as my endpoint, which means that's my endpoint right here. That's also going to be the first coordinate I use on my table. Okay. For my other points, you can use whatever points you want that are bigger than -1. I like to use my perfect squares. So 0, 1, 4, and 9. All right, so under my radical here, I have x plus 1. So what x value is going to give me 0 under the denominator? That's going to be -1. -1 plus -1 is 0. So that's why I picked -1. Okay, 1. What x value is going to give me a 1 here? That's going to be a 0. 0 plus 1 is 1. Okay, 3 plus 1 is 4. So I'm going to pick 3. And then 8 plus 1 gives me 9. So I'm going to choose 8. All right, and then I can just plug those into my calculator, or I can do them in my head, either one. So, if you look over at my equation, I'm going to have, let me change the color. I'm going to have 3, and then -1 plus 1 minus 2. Okay, and then I have 3. I'm going to do 0 plus 1 minus 2. And then I'm going to do 3, and I'm going to do 3 plus 1 minus 2. And then we'll do 8 plus 1 minus 2. Okay, so you can put those all straight in your calculator. I'm just going to do them in my head right here. This is going to be 0. This is going to be -2. This is going to be 1. This is going to be 4. Square root of 9 is 3. That's 9. Minus 2 is 7. So I have -1, -2, 0, 1, 3, 4, and 8, 7. But again, you can just put those all straight in your calculator. That's perfectly fine. Okay, so let's graph them. -1, -2, 0, 1. 3, 4. And then 8, 7. So my graph should curve something like such. It's hard to make a smooth curve. Okay, and then an arrow at the end. So my domain, the farthest left I can go here is -1. The farthest right I can go is infinity. Okay, the range, the lowest I can go is -2. The farthest right I can go is, or farthest up I can go is infinity. So your domain's left and right, your range is up and down. Okay, and that's the first one. All right, second one. Again, I like to start with A, H, and K. So if I write f of x equals A, this time it's cubed root x minus h plus k. So in this case, A is going to be -2, which tells me two things. It tells me I have a vertical stretch by a factor of 2. It also tells me I'm going to reflect across the x-axis because it's negative. Reflect across the x-axis. Okay. H is going to be -4. And then K is going to be 0, which tells me this is left. It's shifted left 4. Okay. So my turning point is HK again. Just like the endpoint was for the square root function. So my turning point is -4, 0. All right, for a cubed root, my perfect cubes I probably want to look for are -8, -1, 0, 1, and 8. So if I have a radical, underneath it is x plus 4. Again, you can pick any numbers you want. You can pick 2 numbers before 4 and 2 numbers after 4. I like to get the perfect cubes. What number is going to give me -8 underneath the radical? Right here, that's going to be -12. -12 plus 4 gives me -8. -5 plus 4 gives me -1. -4 plus 4 gives me 0. -3 plus 4 gives me 1. And then 4 plus 4 gives me 8. Those are going to give me my perfect squares. Okay, so I can plug those in. I have -2 cubed root, -12 plus 4. I have -2 cubed root, -5 plus 4. I have -2 cubed root, right? -3 plus 4. We already have this one. It's already -4, 0, so I don't need to do it again. Cubed root, 4 plus 4. Okay, and you can use your calculator, substitute those all in your calculator, it's perfectly fine. This is going to get me +4, +2, -2, -4. So I can fill those in, 4, 2, -2, and -4. And now I can just graph them all. Okay, so I can go to my pen. Let me go back to red. Okay, I have -12, 4, which is a little bit off somewhere over here. I have -5, 2. -4, 0. -3, -2. 4, -4. So there's my graph. Okay, something like this. All right, domain and range. So my domain is how far left and right I can go. I can go all the way left, all the way right. And then range, I can go all the way up and all the way down. Right, slowly. I go slowly up and slowly down at the end, but I still go all the way, right? So -infinity to infinity. Okay, and there's everything for number 2. Oops. So that's clear. Let's go down to number 3. All right, again, I'm going to put my standard here, a square root x minus h plus k. I'm going to start with the transformation. So in this case, a equals -1, h equals 0, and then k equals -3. So a equals -1, that tells us we're going to reflect across the x-axis. H is 0, so there's no horizontal shift. The vertical shift is -3, so that's down 3. And that means my endpoint is going to be 0, -3, right? It's h comma k. That's my endpoint. H, k. Right here. So that's going to be the first one I put on my graph. Okay, the numbers I want under the radical are going to be 0, 1, 4, and 9. So the only thing under my radical is x, so it's just going to be 0, 1, 4, and 9. I need to plug those numbers in though. So I have negative square root of 1 minus 3, negative square root of 4 minus 3, and then negative square root of 9 minus 3. Okay, which is going to give me -4, -5, -6. And again, you can just use your calculator. Perfectly fine. Okay, so 1, -4, 4, -5, 9, -6. And that's what my graph should look like. Okay, domain and range, the farthest left we can go is 0, all the way to infinity. The range, the lowest we can go is -infinity. Okay, and the highest we can go is up to -3. We got to make sure we use those brackets on the ends. All right. That's good for that one. Number 4 and 5 don't have graphs. If you want a graph, you can just type it in your calculator. You can graph it in your calculator. That's perfectly fine. Okay. I would start with transformations though. So a is -1/2. H is 3. And k is -4. So this means we have a vertical shrink or compression. It also means we're going to reflect across the x-axis, reflect x-axis. Okay, the h equals 3 means 3 to the right. K equals -4 means negative or 4 down, which means our endpoint here is going to be 3, -4. Okay. You can graph this now in your calculator if you want, or you can go do a quick sketch here. So if I do a quick sketch, 3, -4, this is going to go down, right? Because it's negative. It's going to shrink. And so it's going to look something like this. So 3, -4. So my domain should be from 3 to infinity. And my range should be -infinity to -4, right? All the way down to -infinity and then up to -4. All right, if you want to graph it, oops, I exited out here. Yep, let's do this. Okay, so if you wanted to graph it, you just add a graph and then put it in. So -1/2 square root x minus 3 -4, enter, right? And you can see we got to zoom out, so we got to do menu, settings. Nope. menu view. Oops. Go back to the graph. It disappeared, so I gotta type it again. Negative 1/2 square root x minus 3 minus 4. 4 zoom is what we're looking for, right? And then I can zoom out. It didn't enter the graph in, so we're having all sorts of trouble. Square root. There you go, and you can see the graph. And that's negative 3, 4. So you can see that the domain is from 3 to infinity. And the range is up from negative, the bottom, right? Negative infinity up until negative 4. Okay, shifted 3 right, 4 down. So we're good. All right, next one. So this is a cubic function. So right away, I know the domain and range should be negative infinity to infinity. And negative infinity to infinity, because that's the domain and range for all cubic functions, right? But a is going to be negative 2. H is going to be negative 4, and then k is going to be 3, which means it's reflected across the x-axis. We have a vertical stretch of 2. It's going to be left 4. And it's going to be up 3. Which means, again, my turning point is going to be negative 4, 3. Okay, and then again, domain range, it's always going to look like that. If I try and draw a sketch here, though, my turning point is negative 4, 3. It's going to be going down and up like this. So again, negative infinity to positive infinity. Right, and then this is negative 4, 3. And then range all the way down to all the way up. Okay, if we want to put that in our calculator, again, you can. Tab, I can go back up and, whoops. Tab, go up. Let me type in the new one. Sorry. I keep trying to go fast. All right, and then cubed root. X plus 4. Plus 3. Enter. Right, and I mean, graph looks very similar to what I have, right? All right, so that's it for the graphing. The next part, they're going to give us the graph, and then we need to write the equation. All right, so if I look here, n is going to be 2. This is a square root. Okay, the graph usually goes, right? If you graph the original, it goes over 1, up 1, right? So if I do the original, it's going to be 0, 0, 1, 1, 4, 2. It goes over 1, up 1. This one goes over 1, up 1. That means a is going to be positive 1. Okay, and if you take your endpoint here, our new endpoint, h and k, right? So h is negative 4. K is negative 2, which means we're going to have no vertical stretch. So that's fine. And we're going to go 4 down. I'm sorry, 4 left. And then 2 down. Okay, so then you can just fill in your equation. Square root x minus h plus k. So f of x equals, I don't need to write the 1. And then it's x plus 4. Made the square root too big. X plus 4. And then minus 2. And there's my answer. Okay, why is it plus 4 instead of minus 4? So if I have x minus negative h, that's gonna be x plus h, right? Or I can just put the number in, I guess. X minus. Sorry, keep trying to go fast. Slow down here. X minus negative 4, right? That's the same as x plus 4. That's why it's x plus 4. In our equation, it's x minus negative 4 becomes x plus 4. All right, number 7. Again, this is a square root. Okay, so I'm going to have f of x equals a square root x minus h plus k. So we need to know what all of those are. A, so again, usually you go over 1, up 1. This one we go over 1, down 2. That means a is going to be negative 2. It's flipped upside down. And instead of going over 1, down 1, it's over 1, down 2, which means we have a vertical stretch. So if we do this, we have a vertical stretch by a factor of 2. All right, it also means it's reflected across the x-axis because it's upside down. All right, our endpoint is 1, 0, so that means h is going to be 1 and k is going to be 0. All right, which means we're going right 1 for our transformations. So if I fill in my equation, it's going to be negative 2 square root of x minus 1. Minus 1 because h is positive, so it's x minus a positive 1. And there's my function. Number 8, we have a cubic function. Okay, so our standard is going to be f of x equals a cubed root x minus h plus k. So again, usually if from our turning point, we go over 1, up 1. In this one, we're going over 1, up 3. That means a is going to be 3. Okay, and then our turning point, this is h and k. So h equals 0, k equals negative 4. So for our transformations, we have a vertical stretch. And we go left, down 4. So when I fill my equation in, it should be 3 cubed root of x, right? You could write x minus 0, but we don't need to do that. So you really can just write it as f of x equals 3 cubed root of x. And then outside the radical, you can put minus 4. Okay, because again, your original, right, would be 0, 0, 1, 1, 8, 2, negative 1, 1, negative 8, 2. Right, this is my original. So we've shifted it down 4, and then instead of over 1, up 1, we go over 1, up 3. We've stretched it out, vertical stretch. All right, so that's it for 5.3. On to 5.4 here. So the first type of problem you're going to have for 5.4 is solving an equation with one radical. We want to make sure we isolate the radical. We want to get it by itself first and then square both sides, or in the case of a cubed root function or equation, we want to cube both sides. So in the first one, we have square root. So we're going to start by subtracting 9 on both sides. The reason we're doing this is we want to get the radical by itself on one side of the equal sign. So now we can square both sides. So I can square both sides. Okay, so on the left, we're going to end up with x minus 5. And on the right, we're going to get 16. We're going to add 5 to both sides. And I get x equals 21. Okay, I need to make sure I check my answers, so I'm going to plug it back in, substitute it in. 21 minus 5 plus 9 equals 13. That's going to be the square root of 16 plus 9. That's 4 plus 9. I get 13 equals 13. So we're good. This is my solution, x equals 21. And again, you can just substitute that in to the on the calculator. It'll tell you true or false. All right, this one, our radical is already isolated. So I'm going to put each side to the third power because it's a cubed root. Okay, so that's going to give me on the left x minus 8. And then on the right, that's going to be negative 27. I'm going to add 8 to both sides. That's going to give me x equals negative 19. Before I circle it, I'm going to check my answer here. Cubed root negative 19 minus 8 equals negative 3. Well, that's negative 27. The cubed root of negative 27 is negative 3. So we're good. We get negative 19. All right, next one. The radical is not by itself yet, so we need to subtract 27 from both sides because we need to isolate the radical. That gives me cubed root of x equals 3. Now I need to cube both sides. That's going to give me x equals 27. Before I circle my answer, I need to substitute it back in, make sure it works. It looks like it will. The cubed root of 27 is 3. So 3 plus 27, 30 equals 30. We are good. Okay, next one, the radical is already isolated, so I'm going to square both sides. That's going to get rid of my radical, so I get 12x equals 16 squared is 256. I'm going to divide both sides by 12. I don't know. I might have to use the calculator here. 256. I don't know why I can't think of one. Oh, it's not a whole number. Okay, it reduces the 64 over 3. Let's leave it as 64 over 3. So we get 64 over 3. Okay, and then we got to check our answer. So square root of 12 times 64 over 3. Does that equal 16? 4 times 64 is 128. 256. Square root of 256 is 16. We are good. Golden. Our answer works. Okay, so that's first type problem solving with one radical. All right, the second type, you're going to be looking for extraneous solution. So you're going to have to do some factoring and you're going to get 2 answers. And then one of those answers might not work. All right, so we want to make sure we isolate the radical here. It is isolated, so we're going to square both sides. That gives me x squared on the left and 8x plus 20 on the right. I have to move everything to one side so I can factor. That means I need to subtract 8x from both sides. I also need to subtract 20 from both sides. So on my right side, I should get 0. On my left side, I get x squared minus 8x minus 20. I can use my x method to factor. So I need 2 numbers that multiply to negative 20, add to negative 8. That's going to be negative 10 and positive 2. So I get x minus 10, x plus 2 equals 0. So I can do x minus 10 equals 0, x plus 2 equals 0, which means my solutions are going to be x equals 10, and x equals -2. All right, so we need to check our answers and see if either of these are extraneous. So let's just use our calculators for these. Okay, so on the first one for 10, let's check 10. 10 equals square root. I have 8 times 10 plus 20. True. Let's try it with -2. This is going to definitely be a no because you can't take a square root of something and get a negative answer, right? I can't get -2 as an answer here. So that one we probably didn't even need to put in. That was obviously going to be not true. So this one is extraneous. 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 Okay, doesn't work. All right, next one. We already have our radical isolated, so we can square both sides. So on the left, I'm going to get x plus 6 twice. So I'm going to write it as x plus 6 times x plus 6. On the right side, the radical gets canceled out by the square, so I get x plus 6. Okay, I'm going to FOIL first. Outer, inner, and then last. Right, that gives me x squared plus 12x plus 36 equals x plus 6. I'm going to subtract 6 from both sides. I'm going to subtract x from both sides. That gives me x squared plus 11x plus 30 equals 0. And then I can use my x method to factor. That's going to be 6 and 5. So x plus 5 and x plus 6 are my factors, which means my solutions are x equals -5 and x equals -6. Okay, but we need to check for extraneous solutions here. So let's put it over here. All right, so let's do -5 first. -5 plus 6 equals square root -5 plus 6. And then I have -6 plus 6 equals square root -6 plus 6. Okay, and I got true for both of them. So they both work. Neither one are extraneous. All right, last one here. Since the radical is already isolated, I can square both sides. So I get 9x plus 72 on the left. On the right, I get x plus 4 times x plus 4. 9x plus 72. First, outer, inner, and then last. Right? First, outer, inner, last. Combine like terms, 4x plus 4x is 8x. I'm going to subtract 9x and 72 from both sides. Cancel, cancel. I get 0 equals x squared minus x minus 56. We can use our x method, -56 and -1. That's going to be -8 and +7. Which means my solutions are x equals 8 and x equals -7. We got to check them though for extraneous solutions. Okay. So, square root 9 times 8 plus 72. It's 144. It's 12. But let's just use the calculator anyways. And then 8 plus 4 is 12. That one should work. Absolutely. Okay, and then this one's going to give us a negative, so this one's going to be a no-go. Yep, false, right? Because you get square root of 9 is 3. Negative 7 plus 4 is negative 3. 3 does not equal negative 3. So, false. This one is extraneous. Extraneous. Okay, so our only solution is x equals 8. All right, next section, solve an equation with rational exponents. So instead of being in radical form, they're in exponential form, but it's essentially the same thing. We're going to isolate everything that's raised to the exponent, the rational exponent, and then we want to put it to the reciprocal power. So for the first one here, we're going to add 126 to both sides. That's going to give us x squared minus 2x minus 10 to the 3/2 power equals 125. Okay, we're going to raise both sides to the reciprocal of the exponent here, so 2/3. 2/3. Right, so 3/2 times 2/3 is 1, right? So that's the whole point here, is it goes away. Okay, the other side we need to put in our calculator, so we need to do 125 to the 2/3. We get 25. We're going to subtract 25 from both sides. We get x squared minus 2x minus 35 equals 0. We're going to use the x method here. We need two numbers that multiply to negative 35, add to negative 2. That looks like it's going to be negative 7 and positive 5. Which means I get x equals 7 and x equals negative 5. Okay, I need to check and see if they work or not, so I need to put them in the calculator to verify. Okay, so I have, let's see, 7. Let me put that in parentheses too. 7 squared minus 2 times 7 minus 10 to the 3/2 minus 126 equals negative 1. I get true. Okay, I'm going to change the 7 to a negative 5. So delete negative 5. Negative 5. Yep, make sure it's in parentheses. True, so they're both true, they both work. So we're good. Next one. I'm going to divide, you could put everything to the 3/2 power, but I think it's much easier if we divide everything by 0.8 first to isolate what we got. Okay. That should be 80, right? Equals, I think that should be 80. Let's put it in the calculator just to make sure. 20 divided by 0.8. 25, wasn't even close. Which is why we put it in the calculator. I don't know why I thought 80. Okay, I'm going to raise both sides to the reciprocal. So instead of 2/3, I'm going to raise both sides to the 3/2. Right, so far on the left side, that's gonna cancel everything out. X squared plus 2x plus 10 equals, and then let's just put that in our calculator, 25 to the, oops. 25 to the 3 divided by 2 gives me 125. Okay, I'm gonna subtract 125 from both sides. It's 110, by the way. So I get x squared plus 2x minus 15 equals 0. If I use my x method, I need two numbers, multiply to negative 15, add to 2. That's going to be 5 and negative 3. X plus 5, x minus 3. Which means my solutions are negative 5 and 3. Right, if I go to my calculator, I can plug those in. 0.8, and then in parentheses, I got to do another parentheses, negative 5 squared plus 2 times negative 5 plus 110, close the parentheses, put it to the power of 2 divided by 3 equals 20. True. Okay, change it to times 3. And then over here, 3, true. So they're both true. They both are going to work.